Today I'm going to chat with Bev Sanderson from the brand Maysama. Bev is an expert in LED and she's really done a ton of research in the last couple of years. I really do feel you will learn something about LED from this video because I learned some things about LED and I've been studying it for a really long time. I am going to put timestamps in the description box because it's a long video. It's probably about 30 minutes. It is really worth the watch, but I do want you to be able to skip around if you just don't have that much time. Now, I did edit myself out quite a bit because I really wanted to focus on her answers to these questions that I collected from my private Facebook group. So forgive me if right around where I'm talking, it's a little bit choppy. I really wanted the focus to be on her and educating about LED. Now, while she does have this panel, this video isn't all about her panel. In fact, we don't even discuss her panel to the very end of the video. So this video is about educating and about LED so that you learn something, and I promise you will learn something. Okay, I am going to roll this conversation and I will see you on the other side. I would love it, Bev, if you would introduce yourself for those who do not know who you are.
Oh, thank you. Thank you firstly for having me, Penn. It's lovely. Well, my name is Bev Sanderson and I have my own beauty brand, which is Maysama, which is skincare and LED. My background, I studied microbiology and cell biology, and I have a huge interest in photobiomodulation.
Wonderful. So I want to get to the questions from the Facebook group and we can chat along the way as well. First of all, the very first question is basically an overview. What is LED? What can it do? What is LED? How does it help skin health and anti-aging, pro-aging, if you will? And how much evidence is there?
Okay. Well, let's start at the beginning. So LED or red light therapy or photobiomodulation, they're all meaning the same thing. And it's using non-thermal light energy to stimulate biological processes. So what do we mean by that? Well, there's increasing cellular energy in the form of ATP, adenosine triphosphate. That's the cellular energy molecule. It also increases cell proliferation and helps with cell migration, and all those things are really important for processes like wound healing and skin rejuvenation. And if we think about what does it do for skin rejuvenation, well, basically it increases or improves skin tone and texture. So if we look at that in more detail, we're talking about reducing fine lines and wrinkles, increasing elasticity, and reducing erythema, and reducing pigmentation. So it's those things. In terms of evidence and science behind that, gosh, there's over 6,000 papers written on LED. Most of them will be, geared towards medical applications. So you'll find far more around wound healing than you will about skin rejuvenation as such. But the two have so much in common. What do you need for wound healing? You need the cell to generate energy, and you need cell proliferation so that it lays down collagen and heals wounds. What do we need for skin rejuvenation? Those two things, it's the same.
Okay, so the next question from the group is, what's the difference between red and near infrared, and how do they work differently?
Well, they're different wavelengths. So red starts at 600 nanometers and takes us right through to 780 nanometers in the visible light spectrum. And then near infrared, it's not visible, but we're looking at 800 nanometers up to 1400 nanometers. So it's a longer wavelength. And the longer the wavelength, the deeper it penetrates the skin. But they work really well together for skin rejuvenation. They have distinct but complementary action. So red light, if you look at some of the studies, they show that red light is better for reducing melanin. It's better for brightening skin. And near infrared light is anti-inflammatory. It increases microcirculation. And going back to the red actually stimulates the fibroblast proliferation. And the near infrared then takes it to the next level. It takes those fibroblasts and helps mature those fibroblasts into myofibroblasts that then produce and secrete collagen. So they've got this distinct action that works together, and that's why it's really good when you can see studies around red light near infrared light, both give benefits for skin rejuvenation, but you find when they put them together, it enhances that further.
Okay, let's talk about pulsing. I know that you have studied this extensively, obviously. You put pulsing into your panel, and we will definitely discuss that as well. But I want to talk about the science first. It's interesting because along the way in my studies of LED, I remember long ago studying pulsing, maybe 3 or 4 years ago, and some of the really, really expensive lights that you could use in office on clients had that. But not most of the over-the-counter, if you will, LEDs did not. And so I studied a little bit in the treatment room, but then I kind of went away from it because I was looking primarily at home devices. So I do think it's interesting that you have an at-home device that does this. So I would love for you to explain the benefits of that and how you came upon and how you decided to use that version of this technology.
Well, I think it's kind of been overlooked probably in the at-home devices, because pulsing or super pulsing was developed for the medical field, the carbon dioxide laser, because the lasers produce a lot of heat energy. And so that they could use the lasers for longer, they started using pulse light, so you didn't get this buildup of thermal energy that could damage tissue. Mm-hmm. Now, with the at-home LEDs, of course, that's never going to be an issue. It's never going to get to that high energy level where you can potentially have tissue damage. That just doesn't happen with LED, non-thermal energy. So I think, for that reason, many of the benefits of pulse light were overlooked and said, well, we don't need it. But actually, when you start to look at the detail, it's really, really interesting. And for me personally, it came out of a conversation with Andre Sommer. So you might recall, Penn, that Andre Sommer was the German scientist who wrote the original paper, green tea and LED, a powerful duo in skin rejuvenation. And I tracked him down, and we were talking about rooibos, and we got on to pulse light. And he said to me, Bev, he said, if you're using red light for skin rejuvenation, you really should be using pulse light. And I said, well, why? And they use pulse light in their studies. So Andre Sommer has a whole team of scientists who are working on not skin rejuvenation generally. That was kind of a little sideline for him. It's mostly around anti-cancer drugs. So they use EGCG, which you'll know better as green tea, epigallocastine gallate, which is anti-mutagenic. So they use that for treating cancer. And what they find is that if you pulse the light, it helps the cell to take up these anti-cancer drugs. I'll explain why it works. When you turn the light on, it basically has two actions on the cell. But the first one is that it makes the cell, the cytosol, so the fluid inside the cell, swell up. So the cell expands. And then when you turn the light off, the volume of the cytosol decreases and the cell contracts. If the cell is surrounded by micronutrients or anti-cancer drugs, effectively it then sucks up all the micronutrients surrounding the cell. So the action of pulsing the light on, off makes the cell do this and take in the micronutrients. So he said, it really increases the bioavailability of your skincare, and so increases the efficacy of your skincare. And I thought, well, that's fantastic. Why are we not doing this? So that was the first thing. And then there's more, and I think we probably need to understand a little bit more about the action of red light generally to kind of explain the second part. And I know that I've talked, with other YouTubers about how long we should be doing red light for. And there is this kind of tipping point where prolonged exposure to red light has diminishing returns. And it's all to do with this. I don't know whether this is going to work, but this little graph here is the biphasic dose response, that people may or may not be familiar with. So we have this curve. And in the upward part of the curve, the red light is working really well. And then it just reaches this point where it starts to not work so well. And it's all to do with a buildup of free radicals. And we don't get that with pulse light. So when you turn the light on, you get a burst of free radicals. And those free radicals are beneficial. They're signaling molecules. that's what kicks off the whole process, that the cell starts to communicate, and then we get the cell proliferation and all these wonderful things, and ATP increases. But as it carries on building, I said about the 2 actions of red light. The second action of red light is that in the interfacial water layers, it reduces the viscosity of the water layers. But as the free radicals build up in that, the water becomes sticky. And I've got a little tool here, this lovely little motor here. If you imagine, this is the last enzyme in the mitochondrial respiration. We've got this little motor that's running. Now, if that's in treacle, that can't work very well. So when the water gets sticky, that last enzyme, ATP synthase, slows down. So we get less production of ATP. And it also signals to the cell to stop proliferating, not stop driving that cell proliferation when we've got got an abundance of free radicals. We don't get that with pulse light, because you get this initial burst, and then you turn the light off and the cell uses up its ATP reserve, and the free radicals dissipate really, really quickly, it's like milliseconds, because they have this really, really short lifespan. So we get this kind of up, down, up, down, up, down, and that allows it to work more efficiently for longer. So that biphasic dose response that we see there, it would effectively extend the curve higher, possibly plateau, and then eventually it would come down because of hormesis, because you can't have infinite amounts of ATP. It can't go on forever, because ATP will start to inhibit itself, but those 2 things. So if you look at the papers around pulse light, they show you that you get increased ATP production, accelerated cell proliferation. What do we want for skin rejuvenation? We want those dermal fibroblasts to proliferate and lay down collagen. And that's why pulse light is better. So you've got the uptake of skincare, you've got increased ATP production, accelerated cell proliferation, mitigation of abundance of free radicals, so we don't get into oxidative stress. We maintain the redox state of that cell in its healthy state. And then there was one more study by Brondon that showed that pulsing light actually penetrates melanin skin better. He used melanin filters and showed that potentially it's better at penetrating melanin-rich skin. All of that's fantastic.
There are people who will ask if you can get too much LED, and I know what I think. I mean, obviously, it's setting aside pulsing. So we just talked about that. Just regular LED that doesn't pulse. Do you think that you can get too much LED?
I think we need to ask the question, what do they mean by too much LED? Are they worried that it's phototoxic? It's not. It's not going to be phototoxic. But do we get diminishing returns at some point? Yes, we do. Yes. So if we look at that, that graph again, you can see it goes up, down, and then under the line, and we get this inhibitory bit where it starts to inhibit cellular processes. Well, clearly that's not ideal. If we're looking for cells to proliferate to lay down collagen, that's not what we want for skin rejuvenation. For other applications, it may be beneficial, but we're concerned with pro-aging. When we talk about prolonged exposure, we're not talking about how often you do this. It doesn't matter that you do it daily.
The time you do.
It's about a single session.
Right.
So prolonged exposure in a single session. If you do 3 minutes today and 3 minutes the next day, that doesn't matter. It's like if you continued, as you said, for an hour, at some point we're going to reach that tipping point, because you've got the buildup of free radicals during that prolonged exposure.
The next question is it best to use it in the morning or the evening?
Oh, I love that. Well, when you think about where red light and near infrared comes from, if you think about it in sunlight, then we've got a high level of red and near infrared first thing in the morning, which is preparative to protect you against the UV light. And then it's high again later in the afternoon as a reparative, effect against UV light. So I think it really doesn't matter. You can do it in the morning or you can do it in the evening. The important thing is to harness that biostimulatory response that you get from red and near infrared light. For me personally, I just think, you know, what fits in best with my routine for the day? Do I have time to do it in the morning? When am I going to be applying my serums today? And I'm talking about water-based serums, and we'll come on to that. But I'm thinking, oh my goodness, sometimes I switch things up and it really doesn't matter. You know, I just think if I got more time this morning and actually I'm going to use most of my serums now, I'm going to do my red light now. Another time I don't have time to do it in the morning, and then in the evening I take that time and I do my full skincare regime and red light.
I just think that you can use it whenever it fits into your life and when it makes the most sense. So, okay, next is, how long to use it?
You know, it's not just a question of time, it's about dosing. So dosing really is a measure of energy. You know, you've got power density, then you've got energy density plus time, and that's your fluence. It's your energy density plus time, which is measured in joules per milliwatt per minute. And they, you know, they're starting to narrow down that window, which just briefly answering her question, how long for? I mean, most devices will say, you know, about 10 minutes. You can certainly achieve a biostimulatory response with less than 10 minutes with most devices, but you've got to take into consideration the power of that device. So, you know, a mask obviously is going to be lower power than a panel. So typically you would use the mask for slightly longer. But that optimal window is really being narrowed. And I think this is the exciting thing that we're starting to see some discussion around, you know, what is the optimal window? And they've narrowed that down now to 2 to 10 joules per centimeter squared per minute. So if you look at a mask, for example, you know, we talk about radiance, you'll always see a radiance on the website. You won't see energy density because they don't know how long you're going to use it for necessarily. They'll tell you the radiance. And most masks operate at about 28 to 30 milliwatts per centimeter squared. And then panels typically are about 200 milliwatts per centimeter squared. If we convert that to the distance that we're sitting away and the time that we would use those for, you would achieve around 2 joules per 2 joules per centimeter squared per minute with a mask. And then the panel would be the higher end. You're looking at about 4 if you're sat 6 inches away, up to 10 joules per centimeter squared per minute if you're 12 inches away. So, you know, it's people say, how far should I sit from the panel? It actually doesn't matter because 2 joules or 4 joules isn't necessarily better than 10. They're not saying one is better than the other. They're saying this is the optimal window. This is what we've narrowed it down to. So are masks just as effective as panels? Probably.
I do love that there's a window, and what you just said is important. It's not, I think that it's important not to get too caught up in, you know, some of these things because there's this window, but also to refer to the specific device that you're using for instructions and that kind of thing, because each and every one is a little bit different. And then on top of that, don't stress too much because it's a window and you're probably going to fall somewhere in that window. Okay, let's talk about antioxidants and LED. What can you tell us about antioxidants and LED? And what about your latest project with the Nelson Mandela Institute? We can get, that's part 2 of that question. And obviously, I think most people in this community know that your flagship product was your Maysama serum. I would love for you to talk a little bit about that, but also just talk about antioxidants and LED in general when it comes to your studies.
Yeah, okay. I mean, this is the irony of this, Pen. It was you that introduced me to red light therapy. It was you that picked up my serum and went, oh, you know what? I'm going to use that with my red light therapy. And I went, oh, that's interesting. And I went away and did a bunch of research. And the paper that you referred to at the time was the Andre Sommer paper and the green tea and LED. So if we look at, I did a whole research on antioxidants, you know, how are they used with LED, what other antioxidants are there, and there's evidence around not just green tea but guarana, which is similar to green tea but, you know, a plant from Brazil. And then there's evidence around resveratrol, So I'm sure a lot of antioxidants would be helpful. Why are they helpful? Because they buffer the free radicals, and I think we now understand the importance of not having overabundance of free radicals because of these diminishing returns with red light. So if you throw an antioxidants into the mix, then you can keep your red light device working more efficiently for longer. Now, rooibos, yeah, it certainly works as an antioxidant, but this was the interesting thing. You mentioned Dr. Hamblin, and I was lucky enough to have a Zoom call with Dr. Hamblin, and I was explaining to him, we have this serum, and we've just done these independent trials which show that it works really well with red light therapy. It more than doubles the results for skin rejuvenation. And I sent him the data, and he said, Bev, he said lots of things, are labeled as antioxidants, but in reality, probably the mechanism is biochemical and has very little to do with the antioxidant potential of your green rooibos. And within 10 minutes, he was firing papers over to me and saying, look, here we go. It increases mitochondrial bioenergetics. Oh okay. So, it basically it increases or improves the health of the mitochondria and helps them to produce more ATP. Fantastic. Aside from that, there's a third mechanism, which is really interesting about rooibos. So we know that red light stimulates mitochondrial respiration, which drives the production of ATP. We know there's evidence around rooibos also driving mitochondrial respiration. That pathway is known as oxidative phosphorylation. There's an alternative energy pathway. Oxidative phosphorylation is fantastic because it produces a lot of ATP, which is why our cells love it. It produces lots of energy. But this alternative pathway called glycolysis is really, really important because it gives us the building blocks for cell rejuvenation, cell proliferation. You can't just make new cells from having energy in the cell. You need the building blocks, you need the amino acids, you need the lipids, you need the proteins. And glycolysis gives us all those building blocks. Rooibos, or aspalathin from rooibos, so don't forget that Maysama's rooibos is no ordinary green rooibos. It's taken from sustainable farming. It goes through a patented extraction process that concentrates the aspalathin, the main flavonoid in the rooibos, so it's 70 times more potent than standard rooibos. It's the aspalathin that has this ability to look at alternative mechanisms for using the glucose and driving glycolysis that then produces the building blocks for cell proliferation. So it's alternative substrate metabolism is the phrase that they use. So we've got three things going on: antioxidant potential, mitochondrial bioenergetics, alternative substrate metabolism. So those three things, and it's all there in published literature about rooibos. But what I really want to do, Penn, is to put it all under one roof. So, we did the initial independent trial, which was an in vivo trial, just to get some data and say, does it actually work? Because you put information out there and said, using this serum with this, great. And then, another YouTuber went, I don't do that for this reason, because there's not much information around it. Right. And I went, yeah, but you know what? I'd really like to know if it does work. So I went away and did the independent study. And that study was done by a third-party regulatory laboratory with the help of RED, who very kindly provided the equipment for that trial. And it was fantastic to see the data. We nearly fell out of our chairs when we saw it. 260% increase in the results. It's brilliant. But I want to know the nitty-gritty, because my background is science, and it's all very well going, yeah, it works. I just want to know why it works and how it works. You don't get that from an in vivo study. So where I want to throw my money next is an in vitro trial that shows how green rooibos and photobiomodulation work together, and how it looks at these three different mechanisms to work with red light to accelerate and improve the outcomes for skin rejuvenation. And I've literally just signed that project off now. So it'll start in January, and I cannot wait. I mean, obviously it takes time to gather all this data, But, we aim to publish a paper.
I cannot wait to hear what you find out from an in vitro study. I think that that's pretty awesome too. So we will obviously have you back. I will be really interested to hear what you find out and get the nitty-gritty on that too. Let's see. This one is huge. Can you explain to your knowledge the differences between red and near infrared and their impact on pigmentation, particularly like hyperpigmentation?
Okay, well, as best I can.
Yes, same.
We mentioned earlier that there's certainly science and papers and data around red light helping to reduce pigmentation. So that gives me confidence. Then there were our own studies, I say our own, knowing that they were done by a third-party lab that showed that LED reduced pigmentation by 9%. This was using red and near infrared together. When we combined it with the antioxidant, we got 23% reduction in pigmentation. So, even better. I advise to people that if they are sensitive to hyperpigmentation, then just start with red. The evidence is around the red helping to reduce pigmentation. And there is a possibility, more so with panels, I believe, than a mask, that you may get some thermal energy from the device, which potentially then could trigger melasma. Is it directly related to the wavelengths? That's the unknown. So there is no conclusive answer to that, I'm afraid. We don't know all the answers.
You have this fantastic panel. Can you please talk about it for a minute? Tell me a little bit about it. Tell me about the features, the benefits, and just give me a little bit about it so that people know.
We led with the research. We didn't start with a product and then try and get a marketing story around it. It's like the conversation with Andre Sommer just inspired me, and I thought, well, yeah, I want to be using pulse light. This makes perfect sense for me. And if I could design my perfect panel, this is it, because I love the panels that I've been using. I love all the LED devices that I've been using, but sometimes I don't want to stand up. I just want it on the desktop. But then I don't want one that sits on the desktop that takes up my entire desktop. I want something kind of like slim and neat and tidy that's kind of pretty and would look nice on a vanity unit, but it packs a punch and it does what it's meant to do. So I went about working with a supplier to create my own LED panel, which was everything that I wanted it to be. Sleek in design, touch sensitive buttons, and easy to operate, sits on the desktop, but it offers pulse light. Now, pulse light is not for everybody. I'm going to say that because it is quite distracting. It's a big change. You've got used to sitting in front of a lovely red warm light and you can relax. And I personally don't wear the goggles when I just do regular red light, not talking about pulse light. And I was quite comfortable with that. But then if you start using pulse light, it's not that it's detrimental to the eyes. It's no risk to eye health, but it's distracting to the brain. If you imagine you're driving on a sunny day and you go through like a tree avenue, you kind of reach for your sunglasses, don't you? Because you get this flashing, you're like, oh, I can't cope with that. Well, you'll find the same with pulse light. But remember all those benefits that we talked about. We've got better absorption of our skincare, we've got increased ATP production, we've got improved or accelerated cell proliferation, all of these things. That's what you're going to get from your pulse light. So you can start really gently, which is lovely. So if you're used to maybe doing, 6 or 7 minutes with your red light, just add a minute of pulse light on the end. Get used to it. Put your goggles on, but then do a minute of pulse light on the end. And then when you get used to it, you can change it a bit and you can do 3 minutes continuous wave and then stick 3 minutes pulse light on the end. And then when you're ready for it, we always say start with 1 minute continuous wave anyway, because it's important. We want to have those free radicals initially to get that initial burst, to kind of stimulate all those biological systems that we want. But then we just don't want that buildup of those reactive oxygen species, the ROS, free radicals. So switch to your pulse light and it will mean that your device stays more efficient for longer and you're upgrading your red light therapy device. So that's what it's all about.
I will say that your device, when I got it, it is definitely the prettiest LED that I have ever had. And I have had a lot of LEDs. I mean, I do. And I'm going to hold it up for people just so that they can see. It really is. It's beautiful. You did such a good job. I mean, the design alone, I know that's not number one, but you're right. It is nice on the vanity. It looks nice. It does not take up your full desk, but you can leave it on your desk because I truly believe with LED, I have some others in here. Out of sight is out of mind. If you have it accessible, you'll use it more often. And if it's pretty and you'll leave it out, you'll probably use it more often, which all of those things seem not relative, but they are. I so appreciate you coming here. I'm going to invite people to ask some more questions for next time. We will definitely do this again.
Thank you so much, Pen. It was so lovely chatting to you.
You too. Okay. Bye-bye.
Bye-bye.
All right, I hope that you enjoyed this conversation. If you did, please say so down in the comment section. Give our guest a little bit of love. It was so nice for her to take her time and have this conversation. I hope you are having an absolutely wonderful day today, and I will talk to you in my next skincare video. Take care.